Today we will look at a question from the 2009 HSC paper that deals with both projectile motion and electric fields. So let's begin.
In the last video, we were looking at 2009 HSC question 19, and we were asked to find the force on an electron in an electric field, and that force we found to be 1.6 times 10 negative 16 newtons down. The second part of that question asks us, the electron experiences constant acceleration and eventually strikes the detector at D. What is the time taken for the electron to travel from A to D? So they're asking us to work out, first of all, the acceleration experienced by the electron. According to Newton's second law, F equals ma. If you have a force, then you're going to have an acceleration. Acceleration and force go hand in hand. If you have zero acceleration, then your force will be zero. So if you move with a constant velocity, then you won't have, you'll have a net force of zero. So here we have a force, therefore we have an acceleration. So using F equals ma, and knowing that the force from the last question is 1.6 times 10 to the negative 16, we know it's an electron, so therefore the mass of an electron is given from your data table, 9.109 times 10 to the negative 31 times our acceleration. Rearranging the formula, acceleration is equal to 1.6 times 10 to the negative 16 divided by 9.109 times 10 to the negative 31. So we get the calculator out, and 1.6 to the power of negative 16 divided by 9.109 to the power of negative 31, and we get an acceleration of 1.756 times 10 to the 14 meters per second squared. Now this is quite a big number compared to the acceleration due to gravity of 9.8. So if it was outside the electric field, then we would use an acceleration of 9.8. But because it's within the electric field, there's a force, which is quite a small force, but because we're talking quite a small mass, the acceleration on that mass is actually quite huge. So we don't use the 9.8. If, like I said, if it was in free fall on its own outside of field, electric field, then we would have taken acceleration to be negative 9.8, the negative showing down. Okay, so we got acceleration equals 1.756 times 10 to the 14. Now they want the time. How long does it take to travel from there to there? Now this is a projectile motion, and we have it coming out at 60 degrees with a velocity that was given to be, so the velocity it comes out with is 6 times 10 to the 6 meters per second. So projectile motion is a compound motion, so I'll just write the acceleration here. We will need to use it. So when you have a velocity at an angle, the first thing you have to do without even thinking about the question is break it up to its vertical and horizontal components. So we have 6 times 10 to the 6, the angle is 60. So that's our uy, our initial velocity in the vertical direction, and that's our ux. Now uy will be, if you do the trig, it will be 6 times 10 to the 6 sine 60. Now this is just trig, so it's sine 60 is opposite on hypotenuse. So if you just play around with your trigonometry, you should get uy equals 6 times 10 to the 6 sine 60, which is equal to, now sine 60 is 0.866 times 6 exp 6, and we get 5196152.4 meters per second in the vertical direction. And the horizontal direction, we won't be using it, but I'll write it down. That will be 6 times 10 to the 6 cos 60 because we've got adjacent over hypotenuse, and we want to find the adjacent. Cos 60 is a half, so it'll be 3 times 10 to the 6 meters per second in the horizontal, and this is in the vertical. Now, it's important to show direction because we're talking about vectors here, and vectors have direction. So get in the habit of putting the direction. Okay, so now we've got our vertical, horizontal. We got our acceleration in the vertical direction because the force is down, so the acceleration is down. So if the acceleration is down, then we have to use the velocity, which is also down. The equations of motion, we have v equals u plus at. We have v squared equals u squared plus 2a delta y. These are for the y's. And we have delta y equals ut plus half at squared. So these are our vertical components for our projectile motion. We look at our data. What do we have? We have acceleration. We have our initial vertical velocity, and we're asked to find time. Now, we don't have Vy, so we have two unknowns. So what we're going to do is try and work out the time it goes to the maximum height, because what happens at the maximum height? It stops rising, and now it starts to come back down. So we only look at the vertical component. So it goes up, slows down, stops, rising, and then it starts to fall. So the time it takes to go up will be equal to the time it goes down. So we'll find half that time, and then we'll just half the time of the whole projectile, then we'll just double it. So if you're using the first equation, I'll rub off this. So we have Vy equals Uy plus At. Now we said at the top, Vy is 0. Our initial was 5196152.4 plus our acceleration is a negative 1.756 times 10 to the 14 times time. If you notice, I've taken it as negative acceleration because acceleration is down, while our initial velocity was up. So this is the direction. Don't forget, velocity and acceleration are vectors. So we need to put direction. Also, when you move this across to that side, it makes it mathematically correct because you can't have a negative time. So I'm going to move this all to this side. So I get 1.756 times 10 to the 14 t is equal to 5196152.4. I divide both sides by 1.756 times 10 to the 14. Divide this side by 1.756 times 10 to the 14. Get that handy calculator out, and we get 5196152.4 divided by 1.756 exp 14, and we get a time of 2.959 times 10 to the negative 8 seconds. That's the time to go to the top. So the total time, T total, will be 2 times 2.959 times 10 to the negative 8, which is equal to 5.9 times 10 to the negative 8 seconds. So our answer is 5.9 times 10 to the negative 8 seconds is the total time it takes to go from there to there.